first, Nate?
I set it up as x to the negative 3 equals
Yep.
125.
And then when you saw that number 125, what did you think in your head?
5 to the 3.
Exactly. So you saw, so now you have x to the negative 3 is equal to 5 to the 3. That's almost what you want. So what did you do at this point?
1 over x to the
I like that. So you got rid of the negative exponent, and it's what, 5 to the third over 1, like that? And then what did you do?
That's where I got lost.
Well, you could just do this if you wanted to.
Right?
Sure, yeah. So you get, what do you get?
1.
X to the third, 5 to the third is equal to what?
1.
1, right? So what are you trying to isolate, 5 or x?
X.
So you get x to the third is equal to 1 over 5 to the third. How do you get rid of a cube? Cube root it. You take the cube root. What's the cube root of 1? 1. What's the cube root of 5 to the third? So so what you do here is you're taking the cube root, which is 1/3 power. So you get x is equal to 1 over 5. Another way to do this would be, you remember what negative exponents mean? It means you flip over what's on the inside, right? So another way to write this would be x to the negative 3 is the same thing as 1 over x to the what power? To the third. Do you agree with that? Do you see what I mean? If you flip something over, so you could have this. You could have 1 over x to the third is equal to 5 to the third. Well, if you have two things that have the same power that equal each other, what do you know has to be true? 1 over x has to equal 5. And then can you cross multiply and do you get the same thing? Yeah, it's just another path you can take. There are lots of paths. You have to be very careful though. Is it really easy to flip something over the wrong way? Yeah, absolutely. Deb, you had another?
T.
What do you plug in for t? The original value would be right at the beginning of time. What's the start of time?
0.
Yeah, 0. Doesn't it? I think it says where t is the number of years that have elapsed. So 1 would be 1 year has elapsed. So if no time has elapsed, what does t equal?
0.
No time elapsed is time equals 0. So you're looking at v of 0. So you're doing this on your calculator. And what's 2? Well, you can do this on your calculator. What's 2 to the 0?
1.
1. Yeah. So what's that equal to? 500. Second part says, what is the value of the machine 5 years after purchase? So what are you doing? V of what? 5. And do you remember how I told you? This is a good reminder here. Do you remember how I said to do this on your calculator? Put the function in as the first function. What was it? 500 times what? 2 to the negative something, right? Negative 0.15x, like that. Do you remember how you evaluate that first function at a certain value? Do you remember what you use? What do I hit? Vars, and then you select the function, right? And then we wanted it at 0. Press enter. What should it be? Oh, does that match our answer?
Yeah.
And now what you can do is you can do the same thing. You can do the same thing, but what do we plug in instead? 5. So we get a different answer, and that's the kind of answer you would need your calculator for, unless you were a super genius. So do you expect that number to be less? Is that a realistic number to see? 297 like that? Is this a realistic number? Yeah, I mean, it should have gone down. It would have been weird if it had gone up. It implies that it gets less value. What is the value of the machine 10 years? So what do you do for 10 years? You plug in 10. Oh, I just hurt that. That's supposed to be a 500, right?
Yeah.
5. There we go. Looks like a second answer, but instead of 5, I put in what? 10. Oh, good. It's going down. Okay. Well, not good or bad. It's just it is what it is. So there's y of 10. Can you have more than one function into your calculator? Yeah, sure. And then last it says graph the function. How do you go about graphing this function? You're going to need to use your calculator to graph this. So when, the window, though, is really important. What zoom should I use? Anybody? Do what? I like zoom. You say zoom fit? Is that 9? Is it zoom fit? Let me see here. You know, you see it. Oh, do you see? Oh, look at that. Oh, yeah, I think I picked the wrong one. Oh, there's multiple functions. That's why it's confused. Look, when I did this, look in Y1 here. Are there multiple? Yeah. So it just tried to find the best window to show all 3 functions. That's kind of a problem. So zoom, was it 9? Let's see if it changes a little bit. Oh, interesting. It still thinks that that's the window. The other thing is sometimes, oh wait, no. Zoom, we got standard, trig. Oh, zoom stat. Zoom fit is 0. Sorry, zoom fit is 0. So let's, oh, there we go. Yay, it's going down. Is that kind of what we expect it to be? We might want to see more of what it looks like over here, so we want to make the x values bigger and maybe make the minimum y value smaller. What button do I press if I want to modify a specific x value for the window? Just hit window, yeah. So we could zoom, but I want to hit window, and let's make an x minimum. We're not going back in time. Let's go to, I don't know, 4 years. Let's go to 0 for our x minimum. See what this looks like. Nice. So is it depreciating in value? Yeah. Usually what happens, depreciates in value, and then what happens to technology eventually? It stops. And is it a gradual curve? Well, for a while it is, but then generally what happens? It's worth something, it's worth something, it's worth something, and then nothing, right? It'll break or get into an accident or something like that. It'll go away. But that's your general idea of what the graph looks like. Yeah?
Can we please do number 5?
On 10, what number is the base? There's 3 numbers. Which one is the base?
1/2.
Yeah, so it's log base, so it's log 1/2. And then remember, you go in a circle like this. 1/2 to that power equals this. So what goes over here? -3 goes there, and then what goes there? 8. Yeah, that's it. It's a circle. Remember that circle. I've drawn that circle 10,000 times in my life. Because I was just thinking, do I put it in the right place? Because it can get a little confusing. You change the sides, and then the 8 and the 3 get switched, and then the problem doesn't make any sense. Okay, any others? Okay, put it all away except a pencil. Look at this. This says, what did I say? Addition goes to multiplication. And also, so if you're multiplying inside, what does that mean it turns into if you move it outside? Addition. So what does this mean? It means that log of A plus log of B equals log of what? No, log of A times B. When it's inside, it's going to be multiplication, but when it's outside, it's going to be what? Addition. Again, we're not going to prove this. I just want you to use it. I just want you to use it. So look at this one right here, this example. What does it say? Log base 3 of 3x. If you go outside, what operation does it turn into? Addition. And then what is log base 3 of 3? We talked about this yesterday. Do you remember we talked about that? If you have the same base, log base A of A is always equal to what? 1. It's always equal to 1. It's always equal to 1. Log base A of 1, what is that always equal to? 0. It's equal to 0. This is from last class. You have to memorize a few of these things. Those are 2 of them. So what kinds of questions can you be expected to do? Well, you can be expected to simplify things that look like this. Let's do 2 of these right here. These 2. Here's 2. So this one right here, what does x to the 3rd mean? Not a trick question. What does x to the 3rd mean? Yes, it means x times x times x. So what does this mean? Log base 4 of x times x times x. What did I say if you wanted to break that apart? That's a product, so what happens if you move it outside? It turns into what? Addition. So this is going to be log base 4 of x, and then what? Plus log base 4 of plus. Correct. If you break it apart, every time you break apart a multiplication, it turns into addition. What about over here? You have addition on the outside, so what can you do with the numbers on the inside? So this is going to be log base 7 of what times what? So you could write that as log base 7 of, anybody do that in their heads? 96. Thank you. So you can pull them, you can push them together or break them apart. There are 2 very, very, very important aspects to this rule. Do you see this number 7 right here? You see the other number 7? Those are both called what in the logarithm? Those are both the what? Bases. This is huge. They must have the same bases. Correct. To use this addition, exactly. To add them together and to use this rule, they must have the same basis. If they don't have the same basis, this rule doesn't apply. So remember what I said about not making up rules? If you add these together this way and they have different bases, you'll get something that doesn't work at all. They have to have the same base. Log base 3 of 3 times. Yeah. That's about as nice as it gets. What about this one right here? I think we had one right here. Well, What does minus mean? So this, is it the same base?
Yeah.
It better be, or we're stuck. So this is going to be log base 5 of what? 6 over, not 5. Where's that 5 coming from? I don't know. 6 over x. There it is, right there. Can you do anything with that? No. Sometimes you need to decompose it, and sometimes you need to push it together. There are times for each. Sometimes exponents are easier to use, sometimes logarithms are easier to use. It totally depends. It totally depends. There's something that's really, really important. This is super important. Sometimes, remember what I said, you don't want to make up rules? And I've mentioned to you this before. Sometimes I don't like telling you the common mistakes, because if I show you the common mistakes, what happens? You make them. You remember the common mistake. This right here is what we just wrote. Log of A minus log of B is equal to log of what? A over B. Minus is division, right? This is something that's really important. Log of A over B does not equal log of A over log of B. Sometimes people do that. Is that the same thing? No. This right here.
Why wouldn't that be?
Because it's just not. It does not work. I'm just telling you, again, you don't need to prove these in this class right now. I'm just telling you that is not the same thing. It is not, it is not, it is not. And I am hesitant to show you the common mistake, but I'm just trying to give you an example. It's like, oh, you're just cruising along because like the square root of 1 over 2 is the square root of 1 over the square root of 2, so you're done. Yay, it's exciting. So this is what I'd like you to do. Everybody stand up. Find a partner and a piece of the board. Find a partner and a piece of the board.
Can you do number 3?
Sure. Simplify these as much as you can. Simplify these as much as you can. Do those two. Do those two.
Log base 4 plus log base 4. Came in third. Legendary. Algebra 2. So the next class. Some of it is very mind-boggling. Actually, it's a number between. Wait, hold on. That cube is not touching that board. The 4 is only going to 1, so the x is take a stand. You can figure it out. Yeah, good. Why is there an x? Oh, you didn't. Oh, I see. Thank you. Have an x there now. I see. Good. Okay.
Don't do that at all. Don't you did do that.
Mr. C, I feel like I'm going way too far.
Let me see.
But it's not
Correct. Okay, and I can't.
Yeah.
L.
So it's gonna be log
Log is 4, 1 plus what?
plus that.
No.
Plus 3x. Well, I'm confused myself.
Your second line, Rachel, your second line is completely wrong.
This one.
Yes.
So it'd be, it's not 4 and 4 and 4. And then that's the
Alright, so you connect. This unit belongs with 4.
log 4, that's
Yes. Yes. Good. Now, what is log base 4 for? Good. Good. Melissa, what's log base 4 for? What? Yeah, we also didn't do the other side. But why? How did you say plus 3x? Remember the rule. So listen, the rule is log of a times log of 1 plus 1. Where they have a log of Alvin, but 1 is correct over there. Well, how do you simplify log base 4 x cubed? You just did 1 not correct.
X times X minus
What?
X times X times X.
X cubed is x times x times x. Correct.
And then 1 plus 1 plus 1.
Okay, everybody sit down. Everybody sit down. Everybody sit down. Everybody sit down. Sit down now. I need to help you with algebra. That's what I thought I would have to do, so let's do it. So remember what I said, the hardest part about logarithms is staying inside the universe. If you wander outside the universe, bad things happen. You didn't know it, but the danger is you don't know you're wandering outside the universe. And just about all of you wandered well outside the universe. So, let's take a look at this. I like this right here, log base 5 of a squared. That's a minus, right? I like this. That's great. But what is a squared? A times a. So you replace it and not skip a step. You write log base 5 of a times a minus log base 5 of b times c. What did I say you do if you have the product? What does the product turn into? Plus, but there's 2 logs now. Log base 5 of a plus log base 5 of a minus log base 5 of b minus, plus, sorry, like this, plus log base 5 of c. How many of these things do you have? 5, thank you. How many of those things do you have? 2 of them. So you have 2 log base 5 of a minus log base 5 of b minus log base 5 of c. That's minus and minus. I've distributed the negative. Okay. So let's look over here, for example. This is great. It's a 4 and an x cubed. Is the 4 being cubed? No. So it's 4. What's log base 4 of 4? 1. But what is x cubed? X times x times x. So you're going to do a similar thing over here. Instead of a times a, what are you going to have? You're going to have x times x times x. So if I do this out, let me do it on here so you can have the recording here. So if I take this right here, do this one out, you end up with log, as you did, base 4 of 4, plus log base 4 of x cubed. You already said that that's 1, so that's log base 4 of what? X times x times x. Right? Everybody's with me so far? What does the multiplication turn into? So it's 1 plus log base 4 of x plus what? Log base 4 of x plus, how many are there? So you have 1 plus 3 log base 4 of what? X. That would be where you should end up. That should be where you end up. Okay, everybody find the part. Yes, go ahead. Yes. And let me see if you can figure out the shortcut. It helps on one of these. You did this, Lauren. Sorry, Rachel. You did 4, was it log base b of m? Minus log base b of n. And you did some work and you ended up with this. Log base b of m to the 4th minus log base b of n. Anybody see what the rule is?
The 4s make the 4s the leading.
There's a rule that they don't give you in the section, but I will give you right now, which is this. If you have a log b That's the same thing as log of b to the a power. You can go back and forth. You can go back and forth. You can go back and forth with that. That's an extra bonus. No, the base is 10 on all of these. It's just I'm just implying that there's the same base. The cool thing is this thing, the coefficient, can go back and forth.
So what's the base of B?
There's no base of b. The base is 10 in both of these things. The base is 10 in both of those things. But that's a cool rule you can use. But remember, it is quite convenient. What's nice is that you've kind of proven it. Let me write out all the rules for you here. The rules are all right here. Here they are, properties of logarithms. There's the product, quotient, power, and special property. And I just showed you the power rule and the special property I'll tell you in a second. The big ones, the big three, you're going to use 1,000 times. This one, and this one. This is also important, but I'll talk about